Okay, good morning, Year 6. Hopefully I've got this right and this is the starter that you've just had a go at. If you haven't already had a go at these questions, try and have a go at them now. Pause the video and then have a go. If you have had a go, let's go through the answers. So the first one here, get my pen ready, was writing this number in words. So we've quite handily got a space here in each side. So remember, if you've got a number with 6 digits after it, it's a millions number. So it will be 5 million. Then here I've got 775, but I've still got my hundreds here. So this is 775,934. So 5,775,934. So give that a tick if you got that right. This one over here, I've got column addition. So I'm going to put my number underneath. So I've got 13.68 plus 18.9. Now, because I've got a gap there, so I don't get confused, like the other day, I'm going to add a 0. And we're adding today. We were taking away the other day. So I've got 8 add 0 is 8. 2 add 9 is 11. Decimal stays in the same place. 6 add 8 is 14. Add 1, 15. 3 add 1 is 4. Add 1 is 5. So you've got 58, 5.18. Okay. Now here we've got 4.9 times 90. Now times in a decimal by 2-digit number can be quite tricky. So what I'm going to do is I'm going to times by 9. So I'm going to divide this 90 by 10 to make 9. Okay, so I'm going to do 4.9 times 9. So I've got 9 times 9, which is 81. The decimal stays in the same place. 4 times 9 is 36. Add 8 is 44. Now, that's fine, but in the question, I didn't have 4.9 times 9. I had 4.9 times 90, which is 10 times bigger. So I'm going to make my answer 10 times bigger. So instead of being 444.1, all my digits are going to get one place bigger. So my 40 becomes 400. My 4 ones become 4 tens. And my 1/10 becomes 1 1. So I've got 441. Well done if you got that right. Now, this question here was quite tricky. We haven't done perimeter yet this year, so well done if you have had a go at this, and well done more so if you get it right. So it's quite complicated. So when we're finding the perimeter of a shape, we want to add the shape all the way round the outside. So if you follow the red, my little red pen, going right round the outside. Now here, I've got the measurement here and here, and I've got measurements for each side. But when I get to the top, I've got one missing there and one missing there. So I can't find the perimeter until I know what those two gaps are. So if you look, this bit here and this bit here, because it's kind of like a rectangle, oops, so these two lines together would be the same as 89 millimeters. So if I had 89 millimeters and I take away this bit, that's going to leave me with this bit here. Oops. Oh, I don't know what happened there. Let's just get a rubber, but it doesn't seem to. Oh, there we go. Sorry about that. Oh, come on. The joys of technology. There we go. So we've got 89 take away 67. So 9 take away 7 is 2, and 8 take away 6 is 22. So this bit here would be 22. Now I've still got another missing space here. So if I look here, I've got another missing space here. Now that one and that one there will be the same length as 57 added up. Can you see that? So I'd do 57, which is my long length, take away the bit I know, which is 25, will give me the missing bit. So 7 take away 5 is 2, 5 take away 2 is 3. So this bit here would be 32. Now, if I want to find the perimeter, remember you've got to find all the way around. I've got to add up all of these numbers. So I've got 22, add 32, add 67, add 25, add 89, add 57. If I add those all, if you've added those all up together already, the total would be 292 millimeters. Because notice this is millimeters, but the question is asking for centimeters. So there are 10 millimeters in 1 centimeter. So I've got to divide this by 10, which will make 29.2. So if you got that, that is fantastic. So well done. Excellent. The reasoning question at the bottom, hopefully you've had a go at and sent to Miss Second. Actually, we're sending it to me today because it's Thursday. So I will have a look at that when you send it. So let's move on to the main part of our lesson. So we're now moving away from percentage and moving into measure. So what I would like you to do is, you're going to pause the video in a moment, and I want you to write down as many words or phrases that you can think of when you hear the word measure. So I want you to pause the video and write down as many as you can. So hopefully you've already written down as many words as you can, and you'll have lots and lots of different words and phrases. You might have words like length and weight and capacity, which are all things that we do measure. Or you might have words to do with units of measure like centimeters or milliliters or meters or kilometers. So I'd like to see all those words. If you can send me a picture and show me, that would be great. What I want you to do here is in your books or on the piece of paper you've just written on, I want you to have a go, pause the video again, and I want you to match these measures to their definitions. So pause the video, have a go, and then when you're ready, press play, and we'll go through the answers. So hopefully you've just had a go at matching these. So we've got length, first of all. Now length, we don't use length to measure how something weighs. It's not an amount of space or how much solid, liquid or gas an object can hold. It's the measurement of something from end to end. So hopefully you've linked those two together. Now you've got volume is this one here, the amount of space enclosed by a container. Now, this one and how much of a solid, liquid or gas an object can hold, they're quite similar. And you've got two words here which are quite similar. You've got volume and capacity. Now, capacity would normally have is how much something an object can hold. So capacity would be there. The volume is the space that's inside. So that would be that one there. And then that leaves mass. Mass is another word for weight. So it'd be on there. Okay. Now what I'd like you to do is think about these metric units of measure. So when we think about capacity and length and mass or weight, where do we use these units of measure? So these are all metrics. So again, pause the video and then press play when you've had a go. Okay, so hopefully you've had a go. So let's have a look at this one. We've got millilitres. So that one you should have used. We use that one to measure capacity. Millimetres, this one here, is something we use to, I'm sorry it keeps doing that, I'm not quite sure why. Millimetres. Grams, we use to measure weight or mass. The same for kilograms. And we also have ton, a ton. Would go there as well. Then we've got litres, which is capacity, and kilometres, which would be length. So well done if you got those all right. These units of measure we're going to be using over the next week and converting between different ones. So converting between millimetres and kilometres, or grams, kilograms and tonnes, and understanding what they each mean. So let's move on for now. What I want you to do now, once again, you're going to pause the video and thinking about those units of measure, you're going to think about which ones, which would be the most appropriate unit for each of these. For an elephant, a classroom, a water bottle, and the length of a fly. So pause the video and then press play when you're ready for your answers. Okay. So the mass of an elephant. So there's 3 of these that we could use to measure mass. We could use grams, kilograms, or tons. Now, out of those, the biggest one would be tons. So we'd use tons to measure elephants because they're pretty heavy. The length of a classroom. Now, we've got cubic litres. That's for volume. So we wouldn't use those. We could use centimetres. We could use metres, and we could use kilometres. Now, depending on the size of your classroom, a kilometre is 1,000 metres. So it's not likely. Now, we could use centimetres or metres, but centimetres would be counting a long time to do the length of the classroom. So the most appropriate would be metres. The capacity of a water bottle. So here, when you've got a little 3 sign, that means cubed. Normally, we use that sign when we're talking about volume. But this question says capacity. So we've got millilitres or litres. Now, really, you could use either of those for capacity because it depends on the size of your water bottle. Most water bottles that you bring to school are 500 millilitres. So it would be that one. But you might have a bigger water bottle. That wouldn't be ridiculous. If you've got a litre one, that's fine. The length of a fly. So it's not this one because that's the weight. So we've got metres, centimetres, or millimetres. Now, a fly, you could use centimetres. I'm pretty certain there are no flies that are a metre long. That would be pretty terrifying. So it'd be centimetres or millimetres. And in this case, for a fly, millimetre would be the most appropriate. So hopefully you got those right. So what we're doing here is getting an idea of size. Okay. Now we've got an idea of size and we know the units. The next thing I want you to do is think about the amount. So have a go at these ones. Now with the first one, if you think when you take some medicine at home, the spoon of a syringe is normally 5 millilitres. So use that as a way of helping you get these. Press pause and then when you're ready, we'll crack on with the answers. Okay, so the capacity of a glass. Well, it depends on the size of your glass, but if we had 2,000 millilitres, that'd be 2 litres. Not likely in a glass of juice or water if you were drinking. You could have, but it's not likely. Okay, the best estimate here would be 200 millilitres if you were using a fairly decent sized glass, or 20 millimetres. The length of a rounder's bat. We do lots of rounders in the summer in year 6. We've got 50 millimetres, 50 centimetres, 50 metres, or 50 kilometres. Now, 50 metres, if you think about your swimming badge, it's pretty long. Imagine a rounder's bat that long. You wouldn't be able to swing it. So it can't be meters, or kilometres. It must be millimetres or centimetres. Now,